Welcome to the Hudson Institute. I'm Bryan Clark, a senior fellow at the Institute and director of the Hudson Center for Defense Concepts and Technology. I'm joined today for a conversation about joint all-domain command and control by two folks that have been working in technology for DoD for a long time in different areas. And so we're going to talk a little bit about the technologies that underpin JADC2 and some of the challenges and opportunities that we have going forward to implementing joint all-domain command and control. So with me today are Dr. Mark Lewis from the National Defense Industrial Association's Emerging Technologies Institute, where he is the executive director. He previously was the acting principal deputy undersecretary of defense for research and engineering, and as well as being the director of defense research and engineering for modernization. He's got a Doctor of Science in Aeronautics and Astronautics from the Massachusetts Institute of Technology and has been working in the defense field for multiple decades. Dr. James Stewart is also with us from Navy Surface Warfare Center Crane, where he is the electromagnetic warfare chief scientist. He recently completed his PhD from Purdue University in electrical and computer engineering, and also is director of a very interesting set of programs at Navy Surface Warfare Center Crane, focused on countering adversary ISR and communications, which they call Loki, after the Norse trickster god. So some interesting efforts going on there as well. But I wanted to bring both of these technical experts on to talk a little bit about JADC2 and kind of where the department needs to go forward in being able to implement this approach to integrating forces in the field. So to start with, I'm going to open up by giving a couple of remarks about the study that we recently completed at Hudson on JADC2 called One Size Fits None, and how we might need to overhaul JADC2 to prioritize the warfighter. We found that in our research into JADC2, one of the challenges that it's encountered is the difficulty of establishing standards and specifications for the entire U.S. military from the top down, and it's going to take a long time for that to filter down to operating forces in the field. And the challenges we face from countries like China, and as we've seen from Russia and Ukraine, are more immediate, and we don't have decades to be able to implement a JADC2 approach that requires a long requirements process to be employed. So that if you look at how JADC2 is described by its leaders within the department, they use this chart, which is a challenging chart to understand, but what it really boils down to is an effort to try to create a way to allow all sensors, all shooters, all command nodes to be able to talk to each other in any sort of combination in almost any situation, whether it's facing China, as you can see on the right-hand side here, or the DPRK, the Democratic People's Republic of Korea, or North Korea. So this universal approach is being pursued to try to create a way for all U.S. military forces to talk to all other U.S. military forces and be able to execute effects chains in quick fashion to try to gain a decision-making advantage over opponents. So it's very ambitious set of objectives that'll be challenging to implement in a time frame that makes sense given the immediacy of today's operational threats. And then in terms of how it's organized, the organizational construct for JADC2 is a very top-down one. It uses the high-level strategy of the new NDS, the National Defense Strategy, as well as the previous National Defense Strategy, filtered down through the joint warfighting concept, as you see on the right, and a JADC2 strategy for its own implementation. And that gets boiled down into a set of experimentation activities that are being undertaken by the military services, like Advanced Battle Management System for the Air Force, Project Convergence for the Army, and Project Overmatch for the Navy. Those experiments then reveal new technologies that need to be pursued, or new concepts or refined concepts that need to be developed. And then eventually we end up with a set of capabilities that are fielded that are able to integrate all the forces that the U.S. deploys into combatant commander theaters. This approach, this very kind of industrial model of having new capabilities generated and devised from the center out into the field, it maybe made sense during a previous era, but in the current era of technology and operational challenges, this kind of time-consuming industrial approach is probably not appropriate. So what we end up with is JADC2 is likely to fail and is already having difficulty on several fronts. One is the fact that it's got this universalist approach that tries to solve all problems and address all situations simultaneously. The need for multiple homogeneous networks to be employed so that they can talk to each other, the desire to have set specifications set centrally and then employed by a diverse group of actors out in the DoD. The diffuse way that action's being implemented by the services through their experimentation efforts, which is not really tied closely to what combatant commanders need, which is really the ultimate customer of JADC2. And then the fact that the Joint Staff has to rely on the requirements process to do this means that it's going to take a long time to actually be implemented and may never actually be implemented in the form that the JADC2 cross-functional team desires. The challenge, though, that we need to address and what the combatant commanders are facing is that posed by China. So you can see on the left-hand side here, China's military is growing and advancing and creating a difficulty for the U.S. to be able to deter and then counter Chinese aggression, given the size and the capability of the force that we tend to deploy over in the Western Pacific. So you've got this significant numerical disadvantage and a home team advantage on the part of the Chinese that allows them to kind of build out their plans with an expectation of how we're going to counter them, because they're able to operate from their mainland and using internal lines of communication. We're having to come in an expeditionary way to try to fight them, which means they can plan for the fight to happen on terms they can dictate in large part. And if you look at the right-hand side here, that leads to a Chinese planning process that's very deliberate, incorporates multiple cycles of decision-making and planning, and is pretty comprehensively devised to counter the strengths and the capabilities of the United States. So to counter this, the U.S. is going to have to become more adaptable, more flexible, and try to gain a decision-making advantage where maybe it doesn't have a numerical advantage. So this would argue for moving away from the forecast-centric approach that we take with the JADC2 process, the current DoD requirements process, where we attempt to predict the future needs and then build forces efficiently towards those future needs, and instead move towards a more decision-centric approach where we try to give the warfighters in the field more options further into the fight or further into time, so that we can try to create uncertainty for an opponent like China and undermine that deliberate planning process the Chinese depend on. So JADC2 is arguably trying to provide this form of decision-centric planning, because it's trying to connect all forces, all sensors, all shooters, all command nodes. That would give commanders a lot of choices in terms of the effects chains they can execute in the field. So if JADC2 is pursuing this decision-centric approach, the question then is, how are we going to implement it in a time frame that affords us some relevant capability before China or Russia decide to act aggressively towards U.S. allies? The challenge that JADC2 fundamentally is trying to accomplish is integration, joint integration, if you're connecting sensors and shooters and command nodes. And joint integration is something that the U.S. military has been pursuing for decades, since the Goldwater-Nichols Act initially drove the requirements for a joint force. But when Goldwater-Nichols was first implemented, integration really consisted of procedural integration. We just had to train operators to understand how to work with forces from other services. So we have a series of training events and training requirements for officers and enlisted personnel that allows them to understand how to work together. Today, there's so much machine-to-machine interaction required for joint integration that we're having to come up with new technological solutions. So there's a whole form of machine-to-machine integration that has to happen jointly, and that's why JADC2 emerged as a need, as a way to solve this need. So modern joint integration is both human and operational as well as technical. The difficulty, though, is that the first time joint forces actually come together is in the combatant commander theater. So we've got, as you can see in this chart, we devise a force design within the services. We develop those forces within the services and generate them in the services through our force generation processes. The first time forces from one service encounter forces from another service is when they arrive in theater at the combatant commander's location and then try to work together. So this machine-to-machine integration we have to accomplish happens in the field, but we're trying to figure out how to do it industrially from the Pentagon, which is probably not going to work in any realistic time frame to try to make this happen. So we need to think, instead of trying to integrate the joint force in its birth back in the Pentagon in the force generation process, to instead integrate those forces in the field when they arrive there to operate together. That's the most expeditious way to pursue joint integration, is in the field with the combatant commander. So what we argue in the paper is that we should be thinking instead of trying to do JADC2 back in the Pentagon with the Joint Staff, we should be doing JADC2 out in the field with the combatant commanders. And so flip the model from top down to bottom up. So the combatant commanders would need the organizations and the capabilities to knit forces together for the kinds of effects chains the combatant commander needs today, not for some effects chains that may be needed at some future time frame, which really brings the focus on the customer of the forces rather than the supplier of the forces back in the Pentagon. We argue that you need to have some kind of joint task force construct, but it could be any organizational construct that does mission integration on behalf of the combatant commanders, like in this case of this picture, the mission integration for Indo-Pacific Command that needs to happen out in theater. So we think that the integration needs to be done around particular operational challenges. So the Indo-Pacific commander should identify some operational challenges that he needs to solve immediately, and then work to integrate those forces using assistance from the Pentagon. That should be where the focus of JADC2 lies if we're going to really deliver capability to the warfighter in a time frame that matters. So that integration needs to happen though in two different dimensions: technical, as we said, and then operational. So if you think of the stack model we traditionally use in technological integration challenges, you could think of the top two layers of this as being the more operational layers. So development of tactics, which need to happen, using a combination of support systems like experimentation systems and live virtual constructive environments, and then support for logistics and protection to make sure that the forces that are integrated together can operate together and be able to deliver some kind of warfighting effect. So those two layers are the operational layer, and JADC2 needs to address that. JADC2 also needs to address, and this is where most of the focus has been, on the technical integration. So being able to integrate data, communications networks, and then actually be able to have waveforms that integrate with each other to allow data to be passed. So those layers of technical integration are extremely important and been the focus of JADC2, but they need to be paired up with this operational integration as well. And one other thing on here is that JADC2 needs to think of this as a phasing in approach. So it's going to take time for us to get to some kind of highly automated form of machine-to-machine integration among joint forces in the combat commander theater. So there may be an initial phase of manual integration where we're having to build these combinations of forces, these effects chains, in a very hand-tooled kind of way, using things like gateways, like the Bacon gateway, and then software-defined radios where we have to swap out the radio cards to achieve different waveforms. And then over time, those can be increasingly automated using programs such as the ones that are listed here, like Stitches and Dynamo, that are trying to automate the process of integrating the different technology layers. So the JTF that would be charged, or the mission integration cell that would be charged with integrating joint forces, would be able to then use these integration tools to then build effects chains that address the operational challenges that are most important to the combatant commander. So if you're thinking about maintaining your operations from Guam, there's a series of missions that you need to accomplish, whether it's hypersonic missile defense or rapid runway repair. You would need to integrate joint units to be able to do those, using the tools that we talked about in the previous slide. So the JTF could then take a chunk of the forces that are assigned into Pacific Command, integrate them for these different missions through a series of plays. And so these effects chains that accomplish these missions would involve combining different forces from different services and knitting them together to create these effects chains. So instead of trying to create a system where everything can talk to everything, we should instead start down here at the bottom, trying to knit together the things that matter the most for the operational challenges that matter the most. So with that, I'm going to finish up by talking about one example of how that's being done today. This example that I show here is an example that's been piloted right now as a result of the National Defense Authorization Act for 2021, which required DoD to establish a mission manager, in this case, the Strategic Capabilities Office, that would work with combatant commanders, in this case, Indo-Pacific Command, to solve operational challenges that the Indo-Pacific commander identified as being critical to solve in order to support any of the Indo-Pacific campaign plans. So the combatant commander recommends those challenges. They get approved by the Deputy Secretary of Defense. The mission manager, or the Strategic Capabilities Office, will then help the Indo-Pacific Command Organization for Mission Integration. We call it a JTF, but it could be anything. That organization now has to knit together the effects chains necessary to solve that operational problem. So this pilot's going on right now. We think that pilot could be expanded more broadly to support the JADC2 effort. So overall, our recommendations are that we should take the Joint Staff out of this central role in JADC2 and focus it on working with the combatant commanders to identify operational problems. Then the combatant commanders should identify these operational problems and the associated missions or effects chains or plays they need to deliver in order to deal with those operational problems. The services then should continue to focus or continue their experimentation efforts, but increasingly focus them on the things that the combatant commanders care about the most. And then lastly, we need to identify and build out this horizontal infrastructure that you need for the technical integration. So whether it's Stitches or Dynamo or the new GNU radio, these new capabilities that allow you to automatically integrate joint forces from different domains and different services in the field. This horizontal infrastructure is going to be essential to supporting joint integration in the future. And that's really where we focus most of our JADC2 discussions, but unfortunately, there's a whole operational and organizational aspect to it that's been forgotten. That's what we wanted to focus on with this report. So with that, I'm going to stop and I'm going to turn to our panel for some discussion about JADC2 and kind of where the department's going and maybe where we need to go to try to implement the JADC2 strategy as devised. So to start out with, I'd like to ask each of our panelists what where they kind of see JADC2 going. It sets this ambitious goal of essentially ubiquitous connectivity and interoperability, which may not be possible and may not even be desirable if you look at the combatant commanders and what the challenges are that they face. So what should be the objectives for JADC2? What should DoD be trying to do if it's not connect every sensor with every shooter and every command node? So I'll start with you, Dr. Lewis.
So actually, I like to point out as a long-term goal, the idea of connecting every sensor to every shooter. It's kind of a nice aspirational goal, but as I think you correctly point out, there are many challenges along the way to get there. So what I think we really need to think of is short-term goal, midterm goal, long-term goal. And again, I think you've done a really fine job pointing out some of the issues that one would face in addressing those challenges. You know, stepping back, as you pointed out, I was in the Pentagon end of the last administration, starting in fall of 2019, and I used to joke that everyone agreed on the idea of common standards. It's just everyone wanted to use their own common standards, and so getting universal agreement on what those standards should be was quite a difficulty. And you know, I would draw the analogy. What we ultimately wanted was the equivalent of the USB port, where everyone's device plugs in and it just works. But we were a long way from there. As I'm sure you know, one of the things that I would constantly have to remind people is often we have systems that don't connect by design. We actually built these things so that they didn't talk to each other, that they didn't connect, because we worried about security issues. And so now we're trying to not only undo that, we're trying to connect things that were never intended to interact, but we're actually trying to connect things that were deliberately designed not to interact. And of course, that's quite a challenge. I think you did a really nice job also of kind of laying out sort of the steps along the way. And we always viewed it as kind of a three-layer approach. You had 5 layers, but I kind of collapsed some of those layers to really ultimately 3 layers. You've got the hardware layer, you've got the network layer, and then you've got the applications layer. And each one of those obviously requires considerable thought, effort, focus. If you get the first 2 layers right, the hardware and the network, then the application just almost grows organically. But having said that, I think one of the other points I'd make is, and by the way, let me step aside and tell you how much I appreciated this report. You know, JADC2 is obviously an incredibly important enterprise. it's absolutely fundamental to modern warfare, and you gave us all the explanations for why. If you look at the forces that we'd be facing in the Pacific, and by the way, let's not forget about Europe as well, as Ukraine has reminded us. We see the degree to which the Chinese are building up, and obviously one of the ways that we can counter that, when we will have when we would be playing an away game, is to use our capabilities more effectively, and that's what JADC2 obviously does. Same thing in Europe. So thank you for highlighting this. It obviously is a DoD modernization priority. It was when I was in the building. It still is a priority. I think everyone agrees on the importance of JADC2. I always say, it's kind of like Alcoholics Anonymous. The first step is admitting you're an alcoholic. So not that that's a direct analogy, but everyone understands the importance of JADC2. Everyone understands the importance of connecting our systems, of connecting individual weapon systems, connecting sensors to weapons, and also cross-cutting between the services. Everyone acknowledges that. The devil is in the details and how we get there. And your report very, very correctly points out that often top-down direction doesn't work for it. That that the users have to play a role in this. And so thank you for highlighting those points.
Thanks, Mark. Dr. Stewart, I wanted to ask you what. So we've set this pretty ambitious goal of achieving ubiquitous connectivity, through this kind of top-down approach. But so you're working in one of the organizations that is charged with putting this together. So working with other parts of the Navy in Project Overmatch to try to knit together different units that have to talk to each other in a joint context. Do you find that the top-down approach is working, or do you think that the bottom-up approach is something we need to pursue, or is there an entirely different set of objectives we should establish for JADC2?
Yeah, great questions. First, let me say, multi-domain interconnectivity, interoperability, compatibility is absolutely desirable, right? For many reasons, not just the ones that you mentioned before, which are valid, obviously, but also for SA across the battle space, right? A common operating picture. But also would help, kind of from an MSO perspective, it would help with EM fratricide. So spectrum management will for sure be bolstered by ubiquitous, connectivity and interoperability across the battle space for sure. And when you think about the objectives, one school of thought would say that, maybe the JADC2 objectives should be kind of anchored around ConOps and specific scenarios that are taxing now or will be taxing here in the future. You think about enabling technologies like AI and ML and quantum communication and encryption. So maybe JADC2's objectives should be kind of anchored and informed in these game-changing technologies. There's programs like NEVCA, Naval Integrated Fire Control, and Counter Air, and mosaic warfare concepts that are surely geared to address these specific JADC2 objectives. But as far as a top-down or bottom-up approach, I feel like we're going to have to do a little bit of both. I don't think it would be prudent to just completely, kind of do away with all the efforts, all the resources that we've spent thus far with, all the, like Link 16, TTNT, CEC, Link 11, Link 22, which is NATO's, comms link. So I think it's going to be somewhere in the middle where we have that guidance and those objectives from the joint staff, but we're not going to do away with all the efforts we've done thus far.
Yeah, that makes sense. Which you raised a couple of interesting points there, but one of them is access to the electromagnetic spectrum. So, Dr. Lewis, one of the challenges we're going to face with JADC2 is the fact that operating as the away team inside some of these somebody else's backyard, we could find ourselves with a very contested and congested and complex electromagnetic spectrum environment. How should we be thinking about making sure that JADC2 is implementable or executable in an environment where it's going to be difficult to maintain communications?
So, you hit on one of the critical challenges for JADC2. A couple of approaches. One is to actually, if we can operate within an opponent's environment, actually use their own networks against them. That would be extremely desirable. And we had a considerable focus on that. Again, when I was in the building, we had considerable focus on that as part of our 5G to next G implementation. And of course, worrying about security implications, because we want to make sure they're not doing the same thing to us. So that's also absolutely critical. But you're right, spectrum management becomes a challenge, and of course, with all the pressure that the department is under to relinquish spectrum, I think we're going to see some ongoing stresses there. By the way, if I can dive back in, I just wanted to. I think Dr. Stewart got it exactly right when he said, it's not going to be just top down. It's not going to be bottoms up. It's going to be a little bit of both. And one of the analogies that I also draw, I can tell you a number of times I would be in conversations where we talk about the internet and how the internet has obviously evolved and grown in ways that we never, ever imagined when the internet was first created. And from time to time, someone would ask the question, maybe we just start all over again. Maybe, we do an internet 2.0, and I'm sure you and your colleagues have heard this idea. When anyone suggests that, you realize that is just a bridge too far. How would you ever do that? And so the simple answer is, frankly, we can't. So we've got to live within the existing infrastructure that we've got, but build on it and enhance it and improve it. So I just want to emphasize that bottoms up, top down approach, I think, is exactly the way we need to be going.
Yeah, that's a great point, because we argue for this bottom up approach in the report, but really, if you look at it, it's baked into it are several top-down initiatives. So, we don't, you don't have the stack model that we describe unless you've got some top-down direction. We've got combat commander structures, we've got doctrine, we've got O plans, we've got existing communication protocols, which are all being defined from the top down. So there's clearly a lot of top-down elements. Yeah. So Dr. Stewart, so this is what maintaining access to the spectrum and being able to control the spectrum is one of your big jobs down there as the chief scientist for electromagnetic warfare. So how are you trying to be able to enable JADC to work in an environment where your opponent is seeing this as one of our big vulnerabilities, is access to the spectrum? How do we counter that in our efforts to implement JADC2?
That's a great question. I think that's one that keeps a lot of us who are kind of baked into the ongoings of IMSO, specifically advanced IMSO, up at night. So the quick answer would be quantum communication and quantum data transfer, but we're not there yet, right? So I think really, there's projects like RIF mills, right? RF machine learning. There's DARPA projects like COMEX, communication through extreme RF, that are ongoing. They're not that aren't specifically or explicitly tied to JADC2 or overmatch or convergence or the APMS. But I think embedding those types of algorithms into the network will help for sure bolster and ensure that we can communicate and maintain C2 through these contested and congested environments.
So Dr. Stewart, do you see these programs, like COMEX and RIFMLs, these kind of new tools that incorporate to some degree artificial intelligence, machine learning? Do we see those being implemented in the field? I mean, I've seen some examples of that, with like what's going on with the next generation jammer or EPAWS.
Yeah.
Are we able to work through the testing challenges associated with communications and sensing systems that are by definition designed to be able to change their behavior in response to their environment, which is difficult to test on? So how do we work through the testing of those?
Yeah, another great question. We're definitely engaged in quite a few test events. I think LVC is going to help us get there as well, right? So live virtual construction and model-based systems engineering. So there are efforts that are specifically tied to AI and ML and cognitive BW that are helping us kind of get to where we need to be without actually doing data capture, right? Because that's obviously something that's either impossible or very taxing to get. So, but yeah, there's programs out there that are helping us get there for sure.
So, Dr. Lewis, similar question to you. So, this is something you had to deal with in your previous job a lot. Is how do we implement new AI-enabled capabilities that would be essential for JADC2? I mean, so if we're going to maintain the ability to communicate and sense and be able to adapt to enemy action, it seems like artificial intelligence is going to be a key part of that. How are we doing at testing and being able to feel comfortable and validate the performance of these systems?
So, again, I think one of the things I want to highlight, you talked about in your report the importance of doing experimentation. And that's really critical. So I step back. When people talk about artificial intelligence, I always say, okay, what do you really mean? So I'll tell you the quick little story that at one point when I was still in the building, we decided to do a survey of all the activities in artificial intelligence that were underway in the department. And it turned out to be a fool's errand. There were so many programs that were invoking artificial intelligence. And often it was kind of the magic pixie dust that was going to be sprinkled on the program. Okay, we've hit a roadblock, we've got a problem, we've got a challenge. So let's turn on the artificial intelligence and have it fix our problem. And of course, we would joke about going to the artificial intelligence store and buying a can of artificial intelligence. In most cases, when people are talking about artificial intelligence, frankly, there's a lot of buzzwordiness, but a lot of it, what they're really talking about is machine learning. So then step back and say, there is indeed an incredibly significant role for machine learning in these sorts of applications, JADC2, for example. And so the next question then, I think, and as you posed, so how do we experiment? How do we learn about this? And I think we had some missteps in the department. We had some examples where we decided to roll out what we called artificial intelligence, really machine learning, and get it into the hands of the users before it was ready for prime time. And in at least one example that I can think of, we rolled out a capability that was supposed to enhance user capability. It sounded great on paper. It had an incredibly significant, it could have incredibly enhanced these particular users. But in fact, when it was rolled out, the devil turned out to be in the details. It was not really functional, and in fact, made the user's life even more difficult. And I'll step back. I think we all have examples from our daily life where we get some software tool that's supposed to make life easier and actually makes life more difficult. Well, that was the case that we saw. And the problem in the instance that I'm citing is we tried to roll it out to the operator a little bit too soon. And then we also didn't listen to the operator when the operator told us some of the challenges that they're facing. But I think we got some lessons learned from that. And one of the lessons learned is, yes, we need to experiment. We need to play with it. We need to have people get their hands on it, to use it and kick the tires and find out what works and doesn't work and break it before we deliver it to the operators. And I think that's a powerful lesson learned. I think if you look at some of the programs that, for example, the Strategic Capabilities Office has been rolling out, SCO, my hat's off to them, because I think they've embraced that notion very effectively. And so that's what we're going to see with the implementation of artificial intelligence in this domain.
I'm glad so there are a couple of things you brought up there that I thought were really interesting to talk through is the role of experimentation, and getting reps in with a system to feel like you're comfortable with the way it responds and behaves. And which gets to, I think Dr. Stewart mentioned live, virtual, and constructive. So there may be a way to do this in a model-based environment, where I'm doing getting these reps with the system. That's not the hardware in the field necessarily, where I'm kind of exposing our capabilities to opponents. I'm doing it in a closed environment where I'm able to practice and change it up and much more quickly get through a lot of repetitions.
Yeah, exactly. I draw the analogy, if I could, to the red flag exercises that the Air Force does, where we train our pilots against enemy equipment and enemy tactics. We need to do those sorts of activities in a wider range of systems. And I'd love to see us do these sorts of red flag operations where we test out pieces that will ultimately lead to JADC2.
Yeah, exactly. And if you could do, some of that in a virtual environment or constructed environment, then you might be able to do a lot more variability, get more options on the table. So Dr. Stewart, you had mentioned live virtual constructive, and this is an area that I know Crane has done some work in. So how are you using live virtual constructive to help with the difficulty of integrating forces and also doing electromagnetic spectrum operations? Because when we talk about JADC2, a lot of that is happening in the spectrum. It's sensing, sensors have to work in the spectrum, connecting sensors to shooters, and command and control is happening in the spectrum. So how are you using command or LVC to enable that development of those capabilities?
Yeah, so for those who aren't familiar with LVC, right? So it's connecting either through machine learning, through AI, through ML. It's connecting different assets that exist with certain models that may be in the simulation field across labs all over the country and across really the world. So it's allowing us to basically have different ships, different, we could have different formations within a lab environment to do exactly what the both of you just said, right? Just increase reps with uncertainty that we don't have on hand through, again, collected data, collected assets, collected code. So yeah, I mean, it's a tool that we leverage to ensure that before we actually go out to the field, we've got some credible data, some credible information. So when we do perform mission planning and we go out and try to perform a mission, that we've got some level of confidence with our tactics, our TTPs, right? Tactics, techniques, and procedures.
So you had mentioned earlier that really JADC2 might need to start with the ConOps or start with the tactics. So it seems like LVC is a way to work through that integration in advance, whether you're doing that out in Indo-PACOM, where you're getting ready to mount an operation. You could maybe work through it in an LVC environment, or if you're just trying to figure out if the stuff you have that you think is going to work together is actually going to work together. So are you guys building a lot of digital twins or models of existing systems so that you can do this LVC at kind of a pretty detailed level? So it's not just LVC of a black box representing the Aegis combat control system, but it's actually a model of the Aegis combat control system that you're using in that LVC.
Absolutely. And I'm kind of mixing words here because this is an open forum. So ideally we would have a digital twin of every, vessel with most of the assets, if not all of the assets that we would be leveraging during an actual engagement, 100%, right? So then we would understand to a high level of fidelity and confidence how it will respond and will react to certain signals of interest.
That makes sense. Yeah. So, so you find that you're able to use those digital twins, in general, they give you enough fidelity to where you feel like you can actually play out some likely combinations of units and see if that works. From a JADC2 perspective, it's a way of kind of gaming out a play or an effects chain.
Absolutely, right. Without actually being there. And again, without pushing trons into open space. Yeah, which has, issues of its own. But
right.
Yeah, absolutely.
Yeah, so, Dr. Lewis, this idea of digital twins and model-based systems engineering really emerged over the last few years while you were in office, and obviously this is a priority. How well has that effort been mounted by DoD, and are we seeing a future where increasingly we can do a lot of our evaluation, testing, tactics development, even JADC2 effects chains composition, in this virtual kind of environment or constructed environment?
So simple answer is, I think it's actually going extremely well. The department took it extremely seriously, OSD and the services. And we've had a number of new programs that are stepping up, successfully implementing digital engineering, digital twins. The GBSD program, ground-based strategic deterrent, has actually, in my mind, become the poster child for the effective use of digital engineering from the get-go. And ultimately, when we viewed it in OSD, and here at NDIA, we're still very, very, very interested in digital engineering, not just for the capability that it gives you in doing these sorts of evaluations, but also its potential to speed up acquisition, speed up development. And we all talk about how long acquisition takes. And so with digital engineering, it should be one of the tools that lets us overcome some of the acquisition challenges, and then leads to improved sustainment issues. So bottom line, it's extremely critical, and the department is taking it very seriously.
It seems like digital engineering might enable us to work. It seems like it worked through one of the biggest challenges with developing a new program, which is often interoperability with other programs.
Right.
Because obviously we have a sophisticated military that's developed and evolved, and as you said, you can't just stop and then make everything work to a certain standard. So you got to work with what you got and evolve it as you go. And it seems like digital engineering would give us this way to work through the interoperability challenges of introducing a new system into an already existing ecosystem.
Yes.
And this is one of the big challenges with JADC2 is, right, how do we make things talk to each other? Do you think that digital engineering would be something that we could push not the capability to design something from scratch, but the capability to use those tools out to the combatant commander so they can figure out, what effects chains might be possible to implement, in the field? Or is this something that's still going to be more or less a, acquisition organization or a lab function?
So ultimately, I think you're absolutely right that the goal has to be digital engineering, and the digital twin makes its way to the operator.
Yeah.
So we're not quite there yet, but that would be the future vision.
Right.
And that way, you get, and it gets back to the point of experimentation. I now have another tool for experimentation that the operator can utilize. And look, it's one of the many advantages of digital engineering is it makes tweaking my system much less expensive. I can play with it in the digital world, see what happens if, and then implement it instead of actually building it, trying it, and finding out it doesn't work.
Good point. Yeah, very good point. Dr. Stewart?
I was just saying, absolutely, right. So I think the other key thing that we need to think about when we talk about LVC and mission engineering and digital twins is, I feel like we need to get away from just tying that concept to training, specifically LVC, and more for and towards, again, mission planning, mission engineering, and experimentation. I think it's starting to kind of get that bad rap where people just think that, oh, LVC, okay, well, it's a training tool, which it is, and that's an asset that it's a great tool for training. You think about 3D models and being able to pull a bad card off of a ship that you don't have access to, just kind of going through muscle memory just to ensure that you know how to do it. But I feel like we need to start looking at, again, digital engineering and LVC as more of an asset for mission planning and, pre-mission analysis.
Yeah, it seems like pushing that capability out farther and farther to the operator is going to be really helpful. So it's not just something you do back here in CONUS, whether you're developing a system or preparing a unit to deploy. It's something you send out there so that the component commanders and the combat commanders can use it to formulate the force packages they're going to use.
Bryan, if I could jump in too, I want to reinforce a comment that James made also, that in my time in the building, I tried to draw a big distinction between the concept of demonstration and the concept of experimentation. And frankly, too often we fall into the trap of trying to demonstrate something. And in most cases, I find demonstration is to be of much less value, because when I'm demonstrating something, I'm trying to prove something. So I kind of already think I know how it's going to work, and I want to prove it to someone. There are two possible outcomes. If it works, then you have to step back and say, well, who was I trying to prove it to? Usually you don't even know. If it doesn't work, you've just fallen flat on your face. People say, well, your system doesn't work. Experimentation is very different. In experimentation, I know there are things that I don't know. I'm trying to get answers to questions. And so if I do it right, any result is a good result. So in the case of JADC2 capabilities, I experiment with them. I get to the users, I try them out either virtually or in other circumstances, and I accept whatever answer I get. I accept it and I learn from it, and I build on that and I move on. And that's the model we need to have, not just for JADC2, but a range of other technologies. Everything from hypersonics to directed energy to space. We need to be doing this sort of experimentation, learn from what works and doesn't work, and then build from there.
Yeah, that's a great point, because technology is matured. A lot of these technologies have matured to the point where we need to go out and practice with them in the field and see what works and what can be combined with other things to create certain effects, as opposed to, we're not doing the initial engineering to even build a minimally viable system. We've got systems, we've got, in the case of JADC2, lots of communication capabilities, lots of interoperability tools like stitches and other, software-defined radio kind of systems. To get that interoperability, we need to start experimenting to see what works together and what doesn't, and why.
Right.
So Dr. Stewart, this is experimentation, I think, is something that Crane has been doing, a lot of support to. So do you see that, DoD is shifting more effort towards experimentation with systems, or are we still putting a lot of the effort towards developing something in the lab from scratch that, works in the way that we design it, to then do a demonstration? Do you see experimentation taking more of a role? Demonstration.
I do. I think so, especially for IMSO, right? It's so hard. There's lots of issues, I think, right? Lots of concerns when you talk about, IMSO or electromagnetic warfare specific CONOPS.
Yeah.
They're a lot more difficult than communication and or command and control, right? You think about coherent jamming, cooperative jamming, integrated fires, sensors at kind of, at the front lines. All those require a high degree of coordination that I think JADC2 and Overmatch, I think, it's one of the things that they promise. And you have, you can't just assume that things are going to work, when you go up to a mission. You have to experiment, right? So there's lots of, demonstrations and test events that, Crane specifically is involved in, not just Crane, but the entire IMSO community, right? So you think about Silent Swarm and, so anyway, there's a ton, but yeah, I do agree that we are vectoring more towards experimentation, actually getting out there and doing things versus, just building them and hoping for the best.
Well, that's I think a great point to end on, because experimentation was really kind of where we wanted to focus the JADC2 effort on, building those effects chains in the field, experimenting to see what works and what doesn't work, and then evolving them over time, and then use that to develop JADC2 more so than trying to define everything from scratch that'll work from the industrial model of the Pentagon. So I want to thank our guests today. So Dr. James Stewart from Navy Surface Warfare Center Crane, Dr. Mark Lewis from the National Defense Industrial Association, Emerging Technologies Institute. I really appreciate you guys taking the time out today to talk about JADC2 and its implementation. And we look forward to being able to work with you again on this topic down the road.
Bryan, thank you so much for the invitation, and thanks for producing this report. Again, another high quality product from the Hudson Institute that's helping to focus attention and discussion on this absolutely critical technology issue.
Well, thank you very much, Mark. I appreciate it.
Yeah, thank you so much, Bryan. And obviously another great report, a great study again from Hudson Institute. So